Greetings. Up to now, we have looked at only technical dependencies between tasks when scheduling a network. Now I'm going to look at the impact that resources can have. When we looked at technical dependencies, we just looked at the fact that B can't start until A is done. You can't begin framing a house until the foundation is completed. Now we're going to introduce resources and see the impact it has on our schedule. So we have our regular network here, and it spans 8 tasks, and let's say it takes 12 weeks. We have a critical path along there, and in the center of each of the boxes or nodes, we indicate how many resources are needed to do that task. So for example, A requires 2, D 2. Everyone requires 2 except for F, which is 1. And let's assume that these resources are tractors. And let's also assume that both tractors have to be working at the same time to complete the task. You can't have one tractor working and then be joined by a second tractor 1 week later. Both need to be present to do the work that's required. Now I'm going to introduce a constraint, and that constraint is that we only have 2 tractors available to us for this project. And we're going to look at the impact this constraint has on our schedule. Well, we look at activity A, and there's not a problem because it only requires 2 tractors. But when it comes time to starting B and C, each of them requires 2, so we have to make a choice. This is where the heuristics come into play. These are the rules that the computer uses to optimize the schedule. First, it chooses the activity with the least or minimum slack, and if they have the same amount of slack, then the smallest duration. And if both of those are true for the activities, then they choose the one with the lowest ID number. In this case, C has 0 slack and B has 2 weeks of slack. So we go ahead and schedule C, which spans 3 weeks. Once that's completed, we can begin B, which only takes 1 week. Now we can do D, since B and C are both done, and that takes 1 week. And now we're faced with a choice between E and F. The computer runs heuristics and chooses E because it has the least amount of slack, 0. So we go ahead and schedule E. Now we have the choice between F and G. And at first glance, we would think we would schedule G since it has 0 slack. But you got to remember that we've delayed F. We delayed F actually 3 weeks. So it went from having 1 to 0 to negative slack. And so actually it has the least amount of slack, and we would schedule F, which spans 3 weeks. Once F is done, we have the 2 tractors necessary to start G. And then finally, when G is done, we can go ahead and complete H. And we see now that the project has been extended from 12 weeks to 16 weeks. And this often occurs when you have a resource-constrained schedule. The duration or length of the project is extended. So here we have our first resource-constrained project. And as I pointed out, it has been extended from 12 to 16 weeks. The other thing that's occurred is look at the slack in the revised schedule. Remember, before we introduced resource constraints, we had 1 critical path. Now, if you look at how it's set up, a delay in any one activity would cause the project to take longer than 16 weeks. So the networks become very sensitive. All the activities are critical, as you can see here with the slack of 0, and the start and finish times have been changed. So this is a second impact that resource constraints have on a network. First one is extends the duration of the project, and the second one, it increases sensitivity or alters the original critical path.